Welcome to The Explainer. Today, we're going to talk about Python. How did a scripting language, one that was really just built for clarity, become the absolute engine of our modern world? I mean, we're talking about everything from finance to the AI that's changing, well, everything. So think about it for a second. All these massive data science projects, the generative AI that's popping up in pretty much every app you use, they all have this one thing in common. What do you think it is? Well, the answer, and it's not even close, is Python. It's the go-to language for the two absolute biggest fields in tech right now. You've got over half of all Python developers using it for data science, and then another 40+% working directly in AI and machine learning. That's just massive. I mean, that is just an incredible level of dominance. So how did it even get here? How did Python become this indispensable glue that holds so much of modern tech together? Okay, so the story actually starts way back in 1989, over in the Netherlands. There was this programmer, Guido van Rossum, and he had this idea. He wanted to build a language that was, powerful enough to do really complex stuff, but also super simple and clean to read. It was basically a direct response to how cluttered and messy other programming languages were back then. And this focus on readability, it wasn't just some nice-to-have feature. No, it was the core philosophy. And, as it turns out, that became Python's absolute secret weapon for taking over the world. This whole idea is captured perfectly in something called the Zen of Python. It's basically a list of 19 guiding principles for how to write good Pythonic code. And really, it all just boils down to one thing. Clarity and simplicity come first. Always. And what's so fascinating is how this philosophy was a direct shot at other popular languages back then, like Perl. See, Perl's motto was, there's more than one way to do it. Python said, nope. The Python way is there should be one, and preferably only one, obvious way to do it. And that single choice makes all the difference. It makes code so much easier for anyone to read and maintain. And that's the real key to letting a huge global community build complex stuff that all just works together. So because the language itself was so simple and so consistent, it became this perfect foundation. You could just build this massive, incredibly powerful ecosystem of tools and libraries right on top of it. And the language definitely matured over the years. You had Python 2.0 come out in 2000, which added some modern features. But the real turning point, the big one, was in 2008 with Python 3. Now, this was a huge deal because they intentionally broke compatibility with all the old code. Why? To fix some fundamental design problems. It was a really tough transition for a while. They called it the Great Split, but it was absolutely necessary. And by 2020, it had unified and modernized the whole ecosystem. And this really gets to Python's famous batteries included approach. The idea is that right out of the box, you get this incredible toolkit. You've got libraries like NumPy for all your math needs, Pandas for data analysis, Matplotlib for making charts and graphs. These became the absolute undisputed standards. So if you were starting any kind of data-driven project, Python just became the default choice. It was a no-brainer. Okay, so how does Python pull this off? How is it so simple for us, the users, while it's handling all this crazy complexity under the hood? Let's take a quick peek at the engine room. So, a huge reason for its flexibility is that Python is an interpreted language. What does that mean? Well, instead of your code being locked to one specific type of computer, it first gets translated into this universal format called bytecode. Then, that bytecode runs on a kind of digital engine called the Python Virtual Machine, or PVM. And the cool part is, this lets the exact same code run absolutely anywhere. Windows, Mac, Linux, you name it. No changes needed. And on top of that, Python handles all the really tricky memory management for you. You don't have to worry about it. It uses two main areas. There's the stack, which is this fast, temporary space for keeping track of function calls. And then there's the heap, which is a much bigger, more flexible area where all your actual data and objects live until, they're not needed anymore, and Python just automatically cleans them up. It's pretty slick. So you take this technical simplicity and you combine it with all these powerful tools, and what you get isn't just great software. You get huge, lucrative careers and these incredibly vibrant global communities. And the economic impact? It's just staggering. In the US, if you're proficient in Python, you're looking at an average annual salary of over $120,000. And that demand, it's all being driven by AI and data science, which puts a massive premium on knowing this stuff. And in some places, that premium is even higher. I mean, sure, you've got your usual suspects, the big tech hubs like Cupertino, but what's really wild is that even in a place like Nome, Alaska, a pretty remote city, a Python developer can make almost 25% more than the national average. That just shows you the incredible power of remote work these days. But this whole story isn't just an American one. Not at all. This impact is creating opportunities literally all over the globe. And you can see a fantastic example of this happening in one of Africa's top tech hubs. Let's look at Nairobi, Kenya. They call it the Silicon Savannah. An entire ecosystem has just exploded there, all centered around Python. You've got intensive coding boot camps like Moringa School, just churning out job-ready talent. You've got community groups like PyNBO and PyLadies, which are all about collaboration and empowering women in tech. And then you have major international research centers using Python to solve really critical problems in things like bioscience and agriculture. It's amazing. But look, to stay on top, Python has to face its one big historical weakness head-on. For all its amazing simplicity and power, it's just never been the fastest language out there. It's kind of been its Achilles heel. Well, that is, until now. So the next few versions of Python, they're all about one thing, and one thing only: speed. The core developers are making these fundamental changes to get rid of a long-standing bottleneck called the Global Interpreter Lock, or the GIL. Just think of the GIL as this annoying rule that only lets Python do one single task at a time, even if you have a super powerful computer with lots of processors. By finally getting rid of it, Python will be able to run tons of tasks in parallel. We're talking about unlocking a whole new level of performance. So here's the bottom line. Python is systematically getting rid of its biggest weakness, speed, while holding on tight to its greatest strength, which is simplicity. By solving this speed problem, it is positioning itself to totally dominate for at least another decade. And that leaves us with one last kind of mind-blowing thought. If the world's easiest programming language also becomes one of its fastest, can anything really challenge its throne?